Hello everyone. Today we are going to learn how to use a 7-segment display. A 7-segment display, as you can see on the right corner here, it is basically a display which displays numbers, and you can see that we can display all numbers from 0 to 9 using these 7 LEDs. Okay, so there are 7 LEDs over here. So it is 1, 2, 3, 4, 5, 6, and 7. So we can switch these LEDs on and off, and we can create numbers. For example, if I switch on this LED and this LED, it will create a 1. Although this is a 7-segment display, it actually has an 8th LED also, which is the small dot at the bottom. This is basically used to display a decimal point. So this is the 7-segment display. So as usual, I'll basically display the working of an LED first, and then we can work on the rest of it. We can learn about rest of things. So I'll just show you how it works. So I'm going to start the simulation, and when the simulation starts, it basically displays all numbers from 0 to 9 and goes on repeating. Okay, after a 3-second gap, it actually starts with a 0 again. 1, 2, 3, 4, and so on and so forth. Now you can see that it is basically using any of these seven LEDs, 7 segments, to display the number. How is that done? So let us learn how it is done. All right. Now a 7-segment display basically has 7 segments. You can see it is A, B, C, D, E, F, and G. Now please remember the names of these segments, and this starts clockwise from the top. So we start with A on the top on the top. Then we go to B, which is on the right hand side. So we go clockwise. This is C, this is D, this is E, this is F, and in the middle is G. In the bottom right corner is the decimal point. Now we are not going to use decimal point in this video. We are going to use only the 7 segments. Now, 7 segment displays come in different sizes and colors. There are 2 types of displays available: common cathode array segment and common anode. So that means these are basically LEDs and all are connected to each other. If all of them have their cathodes connected, and that is a common cathode, we call it a common cathode. If all of them have the anodes connected, then we say this is a common anode segment display. Now, when you go and go to buy these segment displays, they will ask you, what do you want? Which one do you want? Common cathode one or common anode one? Now, these displays have numbers. So the number SC52, for example, if this is the display that you are purchasing, there the second letter C basically tells us that this is a common cathode display. If it had been a common anode, it would have been SA52 or something. The LEDs in a 7-segment display usually need a series resistor. So these are basically all LEDs, and naturally LEDs need a resistance, because otherwise these will blow as normally LED blows. Alright, the 7-segment displays are usually used with some form of counter, which may need a decoder so that the correct segments are eliminated for each corresponding number. We learn how to use the current how to use a decoder. The diagram shows the connections for the typical 7-segment display. So the display that I actually showed you on Tinkercad has exactly the same connections. All right, there are 5 connections on top. There are 5 connections at the bottom. The common is common in both, so you can use common of this one, or you can use common this one, so you can use any of these. And the connectors are again clockwise. You can see A and B, and then C and D and E and F and G. All right, so this is where you connect the cables, the wires. So when actually A is connected to Arduino and A is given a high, this A segment is going to glow. This is how it works. Okay. All right. Next, this is the internal circuitry of a display. So all A, B, C, D, E, F, G, and D, P, all of them have a common cathode, and common cathode is normally given a low, and all of these are given highs. So this means when there is a common cathode, we give a low to the common, and we give a high to the each of those segments. All right. Each segment is made high to, so this I've already explained. So you just read the last line and you should remember this. So when it is a common cathode, the negative should be connected to the common because it is the cathode. Cathode is negative, and each segment is given a positive, that is a high. Similarly, when there is a common anode display, the common anode display, in this one, the common is given a high, whereas the rest of them, all the segments are given a low. So this is the reverse of the previous one. So in this, common anode is given a positive, that is a high, and each segment is given a negative. All right. Now this is the most important slide of our presentation. Uh, if you see on the top left corner, we have this I have already explained. Now let us say that I wanted to display a 3. So to display a 3, I would basically require A, B, C, D, and G to be switched on. So you can see the table on the right of this is basically A, B, C, D, and G are on, and E and F are off. So over here also, when you see A, B, C, D are on and E and F are off. And this is the most important thing that you need to remember. So you can note it down also. So what is the situation with the A, B, C, D, E, F, G? So it is 1, 1, 1, 1. These are all on. E and F are off, and G is again on. If I see a 5 now, in a 5, A, C, D, F, and G are on. So you can see in this table also A, C, D, F, and G are on. In number 5 here, A, C, D, F, and G are on. And what you see are the numbers 1, 0, 1, 1, 0, 1, 1. Now you need to remember this now. So for 5, we are going to display, this is what is going to, we are going to use. And in fact, you don't need to remember. You can just note it down right now because this is what we are going to use in our program. Okay. All right, let me see just one more. That is number 2, for example. So number 2 has A, B, D, E, and G. So A, B, D, A, and G are on. So if we see number 2, A, B, D, G, and E are on. So similarly, you can see the numbers also here. All right. So you can figure out how these things happen. All right. This is the in the program I'm going to use this. All right. This is an array that I have created in the program. Now, if I see the number 2, for example, so number 2 is 1101101. So if I come here, it is 1101101. So these are the same numbers that I'm using, that I used in the slide over here. Okay. So what you can do now is when we actually write the program, we will be using the same numbers over there. All right. Um, This table also actually shows you the same thing that as before. For example, if you want to display a 2, So this is a 2. So in 2, I will actually switch on A, B, D, E, and G, and so on and so on. Okay. All right. We can also display some hexadecimal numbers also. Hexadecimal numbers are basically numbers from 0 to 9 and A to F. Um, if you know what hexadecimal numbers are, so for example, in your LCD display, you used uh, the base address of 0x20 or 0x3a or 0x4f or something like that. So you will find the hexadecimal numbers are not pure numbers only, that is, they are not numbers 0 to 9, but they have alphabet 0 to F also. Sorry, A to F also. So the A to F can also be generated uh, by this on this digital this thing. So for example, an A can be created like this, B can be created like this, C, D, E, and F. All right. Now a B is written like this, which looks like a 6, but the 6 actually has this segment on. So this is how we differentiate between a 6 and a B. A 6 will have this tail, okay, but the B will not have. Similarly, a 9 and okay, that is not here. All right, A, B, C, D, E, F is done. We can also use create some other letters also. For example, an H or I or L and O and P and S and U and so on and so forth. Similarly, over here we have created C and G and small h and I and N and O, R, U and Y. All right, you can create them. All right. Now that we have created uh, the, we have learned how to use what our display is and how is it basically supposed to be used. We will now start working on our own system. All right. This is the LED that I'm using. When I click on this LED, it actually asks you whether this is a common cathode or common anode. So I'm using a common cathode one. So common cathode one actually means the common. This is the common. I told you that these are the pins. There are pins on top and 5 pins on the bottom. 5 pins on top are basically starting with A and B. This is for the decimal point. This is C. This is common, and I told you there are common on top and bottom. You can use any one of those. I have used the top one. Similarly, we have a D and E and F and G. So these are the ones that we need to connect now. And we have connected one of the commons, that is one on top. I could have used the bottom one. So one on top is connected to ground. So that is connected to negative. Okay, it is a common cathode, it is negative. Now rest of them I'm going to start with A, and A actually I have connected to pin number 2. And I'm going to connect the rest of them, that is B, C, D, E, F, G in series now. For example, B is connected to 3, C is connected to D4 and so on forth, so forth. So this is C, this is connected to pin number 4 and E, F, G and so on and so forth. Okay. The last ones are okay, number 8. Okay, the last one, that is for the decimal point. This is basically the decimal point is connected here. I'm not going to use this in this program, but I have just given the connection. Now how do we write the program for it after this connection is done? So basically we have used what, we have used the ground, and we have used seven pins for the 7 segments, and the 8th pin, that is decimal, for the decimal point I've used the pin number 9. All right, let's start the coding now. Now for people in classes 9 and 10, in class 10 they would know what an array is. Class 8 probably would not know what an array is, but just create it like this. All right, so what we do is we create an array called num array. It is an integer array because it is storing only integers, so zeros and ones are int basically. And this has 10 rows and 7 columns. So this you write exactly as it is. In this you can change the 10 and 7. 10 basically means there are 10 rows. 10 rows means each row is for one of the numbers. Row number 0 is basically for 0, 1 is for 1, 2 is for 2, and so on and so forth. 7 is for each of the segments I'm using the 7 digits. Okay, so the columns basically signify the segments. Row signifies which number are we talking about. So row number 0 basically. So now you can see how the whole array is written. The statement ends over here because the semicolon is here, right? And it starts with a brace, it ends with a brace. And each row is written within braces. And each row is separated from the other row by with a comma. So this is row number 1, there is a comma. Then this is row number 1, and there is a comma, and so on and so forth. There is no comma at the end because there is no row after this. Now you'll basically understand what these rows and columns mean. All right. So now for number 2, as we saw, I showed you there also. So it is 110, 1101. So these are the segments which are going to be on. So A and B is going to be on, C is going to be off, and so on and so forth. In the end, G is on. So after this array is created, now this is going to be created exactly as it is because the numbers are generated like this only. All you can change here is the num array. Okay, the name of the array is num array. Now, in the setup function, we have actually set up all the pins and they are all for output. I'm not going to use pin number 9, so I've not used it here. All right, in the loop, I have used a for loop. I have told you about the for loop earlier also. In the for loop, basically, C starts with a value of 0 and it goes up to 9 and it increases by 1 every time. So when it actually runs, this loop runs for the first time, C is 0. So what do you think this is going to, okay, this is going to digital write on pin number 2. What is it going to write? It is going to write num array C0. Now what is the value of C is 0. So it is basically going to display 0, 0. And what do you think is the 0, 0? This is the 0th row and 0th column, right? Alright, so this is the number that it is going to use. And if it is, you know that if it is a 1, it is a high. And if it is a 0, it is a low. So in the number 0, don't you think A is actually on? So if A is on, which one is off by the way? G is the only one off. Why? Because in the 0, all the segments on the periphery are on, the middle one is off. So what do you think is going to happen? This one, which is actually at the 761, that is, sorry, 061. So this is going to be off. The rest of all of them are going to be on. After a delay of 1 second, it is going to go back up again. Now C is going to be 1. So it is now going to display 10. So what is row number 1 and column number 0, which is this one. And it is now basically displaying a 1 right now. So over here we see that only B and C are on, rest all of them are off, right? So this is how it is basically going to display all the numbers from 0 to 9 with a delay of 1 second. Okay. After this loop finishes, it is now going to give a delay of 3000 milliseconds, that is 3 seconds. And this is going to go back into the loop again. It is going to start the counter again. It starts from 0 and then 1 and then 2 and then 3 and so on and so forth. Okay. Okay, now this program was actually displaying numbers from 0 to 9. What if I wanted a number Not in sequence. I just want to generate those numbers. Okay, so to take a variable value from as input from the user, we'll basically use a potentiometer. So let's bring in a potentiometer, put it somewhere here. Let's do this. And what do we need now? We need to connect this part one terminal to the to the negative. We know that we need to do that. We need to connect it to. We have another ground here, so we'll use that one. Let's make it black. All right. Next, the second one, we need to connect to the positive. This is what we always do. So we'll connect it to the positive. We'll make it red. The wiper we are going to use to take input. Now this input being an analog input, we'll use an analog input. I'll use A0 for it. Let's give it a different color now. So input from the wiper is basically going to A0. So let us code this now. We are going to now take input from the user pin node, pin number A0, and this is going to be input. No need for pull up right now because this is not a switch. Okay, in the loop I have actually deleted the loop over here, the for loop by the way. Let me just take input from the Viper. So I'll say we'll say analog read. It is A0 which I want to read. And because A0 is going to read values from 0 to 1023, but we actually want only from 0 to 9. So how do we map it? We create another variable, say var1 is equal to, we use the map function. In the map function we say var, which is having possible values of 0 to 1023, and I want 0 to 9 only. So this is how we do it. Uh, I'm going to use a variable called C because I've used the same variable there. So C is basically going to get a possible values. So C var is going to get possible values from 0 to 1023. Now C is going to have possible values from 0 to 9 only because we have mapped it that way. So when it is going to be 0, for example, if C is 0, it is going to display the 0th row. When C is 1, it is going to display row number 1 from this array. Alright. So row number 1, for example, is this, and it will display a 1. Okay, so you can see this is working the same way, but it is not actually going into an infinite kind of a loop where it displays 0 to 9. So now I can display any number from 0 to 9. Alright, let us start the simulation. The wiper is on 0, so it is displaying a 0. If I change the wiper, increase this value, it displays a 1, then 2, then 3 and 4. In fact, 3 has gone from in between. Yes, 3, then 4, and then 5, and then 6, and then 7, then 8, and then 9, and then, okay, and then 9 is the last one. So if I bring it down, it also changes. This also changes. So the basic idea of showing you this is basically not to display fixed numbers. I can just take input from the user and do it. I could have taken it as a serial input from the user also and displayed that number. So you know how to do it, right? So today we learned what a 7 segment display is basically, how to use it, what the terminals are, the pins are, what are they used for. We have not used the decimal point. We'll use it in some other video, in the next video maybe, yes. Then we actually displayed these numbers um, from 0 to 9 using a for loop. Then we took the input using a potentiometer, and that potentiometer basically displayed numbers, whatever is the value of the wiper at any point of time. I hope you have understood what has been explained. In the next video, we are going to use of these, more than one of these displays, and then we can see how would we use it. See, each display is using at least 7 of these pins, right? And don't you think if I use two displays only, it will use up almost all the pins over here? Even no, there will be even less. There are not even pins available for the second display. Or am I going to use 4 displays or 5 displays? So we are going to do that in our next video, how to use multiple 7 segment displays. I hope you have understood this. Please give a comment if you have any problem or you need to discuss anything with me, and please subscribe. Thank you for watching the video. See you in the next one.